Those are online. Am I audible? So online, am I audible? Guys, I'm not, those are online. I'm not able to hear if I'm audible or not. Can someone respond? Yeah. So those are online. I'm audible now. Yes or no? Divya and Sai Kalyan, can you confirm?
Audible, sir.
Okay. So now we'll go to the next topic, that is so we'll go to the next topic of equality of matrices. Suppose there are two matrices A and B, where A is defined as Aij. A is having the elements Aij and B is having the elements Bij. You can say that these two are equal if two conditions are satisfied. What are they? Obviously, they should be of the same order. And secondly, each element of A is equal to the corresponding element of B. That is, Aij should be equal to Bij for all values of I and J. That is the condition that is to be satisfied. Am I right? So, this is what is meant by equality of matrices. You can make a note of it. Right. So now we'll see a problem that is based on equality of matrices. So if a matrix that contains the elements x plus 3, z plus 4, 2y minus 7, minus 6, a minus 1, 0, b minus 3, minus 21 and 0 is equal to 0, 6, 3y minus 2, minus 6, minus 3, 2c plus 2, and 2b plus 4, minus 21 and 0. If these two matrices are equal, then we are supposed to find the values of all the variables that are given there. So what are the variables given? So they are x, y, z, and you have a, b, and c, right? So all that we need to do is first check if they both are of same order. Are they? So what is the order of this matrix? 3 cross 3. This is also 3 cross 3. First checkpoint is covered. Second, the corresponding element should be equal. So x plus 3 is equal to 0. Similarly, so this implies x is equal to minus 3. Similarly, z plus 4 is equal to 6, which implies z is equal to 2, right? Similarly, 2y minus 7 is equal to 3y minus 2, which implies 2y will go to the other side, 2 will come this side, y is equal to minus 5, right? Y is equal to minus 5. So x, y, z are found. Now what we will do is we'll compare this. A minus 1 is equal to minus 3, which implies a is equal to minus 2, right? Similarly, 2c plus 2 is equal to 0, which implies c is equal to minus 1. Similarly, what can we say? B minus 3 is equal to 2b plus 4. Take b to the other side, 4 this side. It will be in such a way that b is equal to minus 7. So we found the values of A, B, C also. We clear? Done? Next. So example number 5. Find the values of A, B, C, and D from the following equation. So since these two matrices are equal, what is the order of this matrix? 2, 2 cross 2, and this is also 2 cross 2, right? So 2a plus b is equal to 4, right? Similarly, a minus 2b is equal to minus 3, right? So I have a linear equation, two linear equations in A and B, so we can solve it. So how are we going to solve it? So I'll write it here, A minus 2B is equal to minus 3. So I'll multiply the first equation with 2. Okay, I just thought I'll eliminate B. So this will become 4A plus 2B is equal to 8. So add them, 2B and 2B are gone. 4A plus A is 5A is equal to 8 minus 3 is 5, which implies A is equal to 1. When A is equal to 1, substitute it back in any one of the equation. I'll put it in the second equation. When I put A is equal to 1 here, I'll get minus 2B is equal to minus 2. Because if I put 1 here, 1 will go to the other side. So it will go as minus 1. So it will become minus 4. So minus 2b is equal to minus 4. So b is equal to 2. Right? B is equal to 2. In a similar way, to find C and D, I'll take the elements in the second row. So what will we get? 5c minus d is equal to 11. Similarly, 4c plus 3d is equal to 24. So the first equation, I'll multiply it with 3. So when I multiply with 3 and write it at the bottom, it is going to be 15c plus 3d is equal to 33. Now, if you're going to sorry, 15C minus 3D So 15C minus 3D is equal to 33. When you add both 3D and 3D are gone, 15 plus 4 is 19C is equal to 33 plus 24 is going to be 57. So C is going to be equal to 3. Right? So when C is 3, when you substitute it back, I'm substituting it in the first equation. So 15 minus D is equal to 11, which implies D is equal to 15 minus 11 is going to be 4. So A is 1, B is 2, C is 3, D is 4. Clear? Clear with this? It's a simple problem, no? Right. So with this, we are ready to solve exercise 3.1. So look at the first problem. Try to do it on your own. It's a very simple one. So the first problem of exercise 3.1. In the matrix A, which contains the element 2, 5, 19, minus 7, 35, minus 2, 5 by 2, and 12, root 3, 1, minus 5, and 17. First, we need to write the order of the matrix. Order is row by column. So, how many rows are there? 3 rows. And how many columns are there? 1, 2, 3, 4. So, 3 cross 4 or 3 by 4 is the order. What are the number of elements? Obviously, 3 into 4, which is going to be 12. It has 12 elements. Write the elements A13, A21, A33, A24, and A23. So A13 is the element in the first row and the third column, which is going to be 19. Similarly, what is A21? Second row, first column. So which is going to be 35. What is going to be A33? A33 is third row, third column, which is going to be minus 5. What is going to be A23? Second row, third column, which is going to be 5 by 2. Second row, third column. Yeah. So there is A24 also, no? So A24 is equal to second row 4. It is going to be 12. Right? So let me know if I can proceed. Shall I proceed? Right. If a matrix has 24 elements, sorry. Yeah, there is some problem. Yeah. So if a matrix has 24 elements, what are the possible orders it can have? So if you look at 24, is it a prime number or a composite number? It's a composite number. So it can be written as a product of prime numbers, right? So it can be 1, 24. It can have the order of 1 cross 24 or 2 cross 12, or it can have 3 cross 8, or it can have 4 cross 6, or it can exactly have the reverse also. So what will it have? It will have 6 cross 4, 8 cross 3, 12 cross 2, and 24 cross 1. So how many such matrices are possible? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 such matrices that are possible. Right. It is actually basically of order 1 cross 24 to 4 cross 6. From there, it is exactly reverse. Right. Now, the next question is, what if there is a matrix which has 13 elements? So only 2 possibilities are there, because 13 is a prime number. So it is going to be 13 into 1. So it will be 1 cross 13 or 13 cross 1. That's it. Right. Clear with this? Shall I proceed? Okay. Now, if you see, what is the third problem? Yeah. If a matrix has 18 elements, what are the possible orders it can have? Again, 18. How are you going to break it as? 1, 18, 2, 9, 3, 6. 4 doesn't work, 5 doesn't work. Again, it starts with 6, so it will become reverse. 6, 3. 7 doesn't work, 8 doesn't work. It will be 9, 2, and 18, 1. Right? So basically 3 into the same in the reverse order. Right? Which is going to be 6 matrices. Am I clear with what I meant by 3 into 2? Right? Okay. Now, what if there are only 5 elements? How many matrices can you write? You can only write 1 cross 5 or 5 cross 1. That's it. So how many matrices are possible in this case? It is 2. Right? So it's a simple problem. Shall I proceed? Okay. Fourth question is, construct a 2 cross 2 matrix where the name of the matrix is A and the elements are Aij, whose elements are given by this relation. So if I take the first one, Aij is equal to I plus j the whole square divided by 2. So for 2 cross 2, what did the elements be? 1, 1, 1, 2, 2, 1, 2, 2. So start with A11. A11 means I should put I as 1 and j also as 1. When I put it, 1 plus 1 the whole square is 4. 4 by 2 is going to be 2. So what is A12? 1 plus 3 the whole square, which is 9 by 2. Similarly, what is A21? So it is also going to be 9 by 2, and A22, which is going to be 4. 16 by 2, which is going to be 8. So what are the elements? 2, here 9 by 2, 9 by 2, and 8. This is going to be the matrix where the elements follow this condition. Right? Similarly, when we go to the second one, right? When we go to the second one, Aij is equal to I divided by j. Am I right? So what is A11? A11 is 1. What is A12? 1 by 2. What is A21? A21 is 2 by 1, which is 2, and A22 is going to be 1. So what are the elements? 1, 1, 1 by 2, 2, 1. Right. So here if you observe, both were 9 by 2. Right here, 1 half 2, 1. Similarly, if you take the third set, right, Aij is equal to I plus 2j the whole square, the whole divided by 2. So what is A11? 1 plus 2. So it is going to be, no, A11 is 9 by 2. A12 is going to be 1 plus 4, 5. 5 square is 25. So it is going to be 25 divided by 2. Similarly, what is A21? 2 plus 2, that is 16 by 2, which will be 8. And what is A22? 2 plus 4, 6, 6 square is 36, 36 by 2 is 18. So what are the elements going to be? 9 by 2, 25 by 2, 8 and 18. Right? So number of all possible matrices of order 3. எப்படி எழுது ஆமா. So ரெண்டு எலிமெண்ட் தானே இருக்கு. ரெண்டு எலிமெண்ட் வச்சு you can write 2 power 9, 512 matrices. எல்லாமே 0 இருக்கலாம். அது மாதிரி combination. So ரெண்டு எலிமெண்ட் 2 elements raised to the power of order of the matrix 2 power 9, 5 power. 2 power 10 is 1024. Right? I'll be back. Okay. Shall we proceed? Or are you people copying, by the way? Sorry. You're done copying? Okay. So moving on to the next one, fifth question is, construct a 3 by 4 matrix whose elements are given by Aij is equal to half of mod of minus 3i plus j. So let's take the first question. So when I take the first question, Aij is equal to half of mod of minus 3i plus j. So what are the possible elements that you will have? A11, A12, so A13, A14. So what will be the last element? 4, 4 in row. It will be A34. You will have 3 rows, no? Okay. So what is A11? A11 is going to be half into, so minus 3 plus 1. Minus 3 plus 1 is minus 2. Mod of minus 2 is 2. So 2 by 2 is going to be 1. I hope you're comfortable with this way, right? I can directly do it. Yeah. So what is going to be A12? Half of, observe, here you put minus, here you put 1, minus 3 plus 2. Minus 1. So mod of minus 1 is 1. So 1 into half is half. What is A13? So minus 3 plus 3, 0. Right. Similarly, A21. A21 is going to be minus 6 plus 1. It is minus 5. So mod of minus 5 is plus 5, 5 by 2. What is A22? When you put 6 here, 2 here, minus 6 plus 2. So mod of minus 4 is 4, 4 by 2 is going to be 2. What is A23? So minus 6 plus 3, minus 3, so 3 by 2. What is A31? Minus 9 plus 1, minus 8, mod of minus 8, 8 by 2 is going to be 4. So A32, what is A32? Minus 9 plus 2, minus 7, so mod of minus 7 is plus 7, 7 by 2. So A33 is going to be minus 9 plus 3, so 6, 6 divided by 2 is going to be 3. So we directly created the matrix. So what is the matrix going to be? It is going to be, yeah, sorry. So we have A14. So what is A14? Half into minus 3 plus 4. So it is going to be 1, 1 by 2. A24. A24 is, so when I substitute 2 here, minus 6 plus 4, 2 by 2 is going to be 1. So A34. So when I substitute 3 here, minus 9 plus 4, so 5, 5 by 2. So the matrix is going to be 1, half, 0, half. Second row, 5 by 2, 2, 3 by 2, 1. Yeah. 4, 7 by 2, 3, and 5 by 2. All the elements are going to be obviously positive. Right? Okay. Shall I proceed? So next question says, the second one says, Aij is equal to 2i minus j. So what is A11? A11 is 2 minus 1, which is going to be 1. What is A12? 2 minus 2, which is 0. What is A13? So 2 minus 3 minus 1. So what is A14? 2 minus 4 is minus 2. Correct? Okay. So next is going to be A21. So A21 is 3. What is A22? A22 is going to be 4 minus 2, which is going to be 2. So A23 is going to be 4 minus 3, which is 1. What is A24? So A24 is going to be 4 minus 4, which is a 0. Similarly, what is A31? 6 minus 1, 5. What is A32? 6 minus 2, 4. What is A33? 6 minus 3, 3. What is A44? Sorry, A34. 6 minus 4, minus 2. Right. So what is the set going to be? It will be 1, 0, minus 1, minus 2, 3, 2, 1, 0, 5, 4, 3, minus 2. Right. 5, 4, 3, minus 2. A34 is 6 minus 4, yeah, plus 2. So it will be plus 2. Clear? Right? Next. So sixth one is, these are the questions that are based on equality of matrices. Right? So they are based on the equality of matrices. Here, if you observe, it's a 2 cross 2, and this is also 2 cross 2. So for the first question, if I compare on both the sides, 4 is y, 3 is z, x is 1. That's it. Right? Second. So y is 4, z is 3, x is 1. Right? Z. Okay. Similarly, if I take the second question, x plus y is 6. Similarly, xy is equal to 8, and 5 plus z is equal to 5. So 5 and 5 will get cancelled, which implies z is equal to 0. Is the point clear? So z is equal to 0. X plus y is equal to 6, xy is equal to 8. So how to solve this? Whenever you have sum of two numbers and product of a number, what you can do is, you can always consider x minus y the whole square is equal to x plus y the whole square minus 2xy. So this is an identity. Why I took x minus y the whole square is because I have x plus y is equal to 6. From x minus y, I'll get linear equation. I can solve it by adding and subtracting. Is this step clear? So a plus b the whole square is, sorry, a minus b the whole square is going to be a plus b the whole square minus, correction, it is going to be 4xy. Okay. So a minus b the whole square is a plus b the whole square minus 4xy. So a plus b the whole square is 36 minus 4 into 8. That is going to be 32. What will the answer be? It will be 4. So x minus y the whole square is equal to 4. Then what is x minus y? Plus or minus 2. Right. So when I solve these two, x plus y is equal to 6. Okay, now observe, when x plus y is equal to 6 and x minus y is equal to 2, we cancel this. 2x is equal to 8, x is equal to 4. Similarly, x plus y is equal to 6, x minus y is equal to minus 2. When you solve these two, sorry, x minus y is equal to minus 2. Okay. When I take this and solve, I'll get 2x is equal to 4. I'll get x is equal to 2. So when I substitute x is equal to 4 here, then what will the value of y be? Y will come out to be 2. When I put x is equal to 2 here, y will come out to be, when I put 2, y will come out to be 4. So what will happen in this question is, x can take the value 2. If x takes the value of 2, y will take the value of 4 and z will take the value of 0. Or what can happen? X can take the value of 4 and y will take the value of 2, but z will still take the value of 0. Am I clear with this? Right. Just for you to validate, what you can do is xy is equal to 8. No, 2 into 4 is also 8. 4 into 2 is also 8. Just to validate. Similarly, x plus y is 6. 2 plus 4 is 6. 2 into 4 is also 6. Are you able to understand? So these are the two answers that you are supposed to report for this question. Clear? Shall I proceed? So the next question is, x plus y plus z is equal to 9. Similarly, x plus z is equal to 5 and y plus z is equal to 7. Right? Now, if you see, when you take this y plus z, how much is the value of y plus z? Take it and substitute it here. So x plus 7 is equal to 9. X will be equal to 2. When x is 2, substitute it in the second equation. When x is 2, when you substitute it here, z will come out to be 3. Right? When z is equal to 3, substitute it in the third equation. You will get y is equal to 4. So what is the answer? Answer will be x is equal to 2, y is equal to 4, and z is equal to 3. Clear? Shall I proceed? Now, if you look at the seventh question, find the value of a, b, c, and d from the equation a minus b, 2a plus c, 2a minus b, 3c plus d is equal to minus 1, 5, 0, 13. So a minus b is equal to minus 1. 2a minus b is equal to 0. Right? So minus, plus, and minus. So when you cancel them, it will be minus A is equal to minus 1, which implies A is equal to 1. So when you substitute A is equal to 1 here, when you put 1 here, 1 minus B is equal to minus 1, which implies B is equal to 2. So A is 1, B is equal to 2. Right? Having said this, if you take this one, 2A plus C will come out to be 5. 2A plus C is 5. Similarly, 3C plus D is equal to 13. Right? 3C plus D is equal to 13. Now you already know the value of A. Substitute it here. So 2 into A is 1. 2 plus C is equal to 5. Then how much will C be? C will be equal to 3. When you take the 3 and substitute it here, this implies 9 plus D is equal to 13. So D will be equal to 13 minus 9, which is going to be 4. So the answer is 1, 2, 3, 4. Am I clear with this? Shall I proceed? Yeah, listen to this. 8th question is matrix A is equal to Aij of order m cross n. It's a square matrix if, very simple, m is equal to n. Right. So the answer will be C. Right. So that comes from the definition of a square matrix. The next question is, which of the given values of x and y make the following pair of matrices equal? Right. So if I compare it, 3x plus 7 will be equal to 0, which implies x is equal to minus 7 by 3. Right. Similarly, y minus 2 is equal to 5, which implies y is equal to 7. If I compare these two, y plus 1 is equal to 8, which implies y is equal to 7. And 2 minus 3x is equal to 4, which implies 3x is equal to minus 2, which implies x is equal to minus 2 by 3. So with respect to y, there is no issue. Whereas x is taking two values, which is not possible to find. Right? So they are not equal. Okay. They should not. They should give you marks. Because you will choose either of them. They'll say one answer is right, but you will get two answers. The option check. Or and Gurta, then you can pick, but that's not possible. And x cannot have two values. X cannot take minus 2 by it cannot be or. Then also the answer will be not possible to find. And if you take this minus 2 by 3 and substitute it here, you will get 0. Whereas if you substitute minus 2 by 3 here, you will get 4. Whereas if you substitute minus 2 by 3 here, you will not get a 0. So it cannot be or. It is still not possible to find because they both are not equal. So 10th one is total number of all possible matrices of order 3 cross 3. So when I say 3 cross 3, how many elements are there? So it has 9 elements. But what they are saying is, among the 9 elements, you are supposed to use the data of only 0 or 1. Right? You have two numbers in your hand. You need to use only these two numbers. You can place it in any combination or any permutation or any combination that you want, but they should have only these two. So if you see, for the two elements that are there, 2 power, the number of elements that are possible in the matrix will come out. So it will be 2 power 9 matrices, which is going to be 512 matrices that are possible. Okay. Shall I proceed? It's simple, no? No. So now we will see the content that is needed for us to solve the exercise 3.2, right? So here we are going to start dealing with the operations between different matrices that are there, right? Obviously, when I talk about operations, what comes to your mind? Addition, subtraction, multiplication, and division, right? We have addition of matrices, we have difference of matrices, we have multiplication of matrices, but there is no concept of division of matrices. So division is not possible in case of two mathematical operations. One is matrix, one is vectors. So there is no concept of division of vectors also. Okay. So having said that, first we'll get started with the concept of addition of matrices. Let's take a problem statement. Suppose Fatima has two factories, which are A and B, and each factory produces sports shoes for boys and girls in three different price categories labeled 1, 2, and 3. Okay. So the quantities produced by each factory are represented in matrices given below. So they have given us the data set in which format? In the matrix format, right? So factory A is producing. So each factory is going to do the same thing. What will it do? It will produce the same sports shoe, right? But the costing is different. That's it. So from factory A for boys, if you see the price category 1 to 3, they're like this 80, and for girls it is 60. Right. Similarly, the second category it is 75, 65. Third category 90, 85 from factory A. From factory B, for the first category it is 90 and 50 respectively, 70 and 55 respectively, 75 and 75 respectively. So this is the data set we have in our hand. Now the question is, right? Now the question is, suppose Fatima wants to know the total production of sports shoes in each price category, then what will she do? Right. So since you are saying the word, using the word total means you need to add them, right? So in each price category, in price category 1, what is she going to do? She will take the data set from the first factory, data set from the second factory, add them in a respective order, right? So in category 1, what will happen for boys? What is the data we have? 80 plus 90. And for girls, it is going to be 60 plus 50. Similarly, in category 2, what will happen? For boys, it is going to be 75 plus 70. And for girls, it is going to be 65 plus 55. Right? Similarly, here boys, it is going to be 90 plus 75. And for girls, it is going to be 85 plus 75. Basically, you're just adding the corresponding values. Right. So here each data has a meaning associated with it. But when you look at it in the form of a matrix, what can you say? This is A11, this is B11. So when you add the corresponding elements of ith row and the jth column. So A11 is added only to B11. You need to look at the subscript. Similarly, A12 is added only to B12. You don't add the other way. You don't add in the other way at all. Is that clear? So by doing this operation, if suppose you want to represent this result in the matrix form, then how are we going to do it? It is going to be 80 plus 90, which is going to be the first element. Similarly, 60 plus 50, like this, you will write the whole set. So you'll take this and put it in the corresponding row and the column. I hope that part is clear. Right. Now, based on this example, if we need to give a definition to matrix addition, let's see how we are supposed to define it. Okay. So before that, we need to understand one thing. When you add a matrix to another matrix, the output that you get is also a matrix. Okay. So the new matrix is the sum of the above two matrices, right? We observe that the sum of the two matrices is a matrix obtained by adding the, I told you this word, adding the corresponding elements of the given matrices. Furthermore, the two matrices should have, when you need to add the corresponding elements, you need to ensure both the matrices have same order. If they are of different order, there is no concept of addition of matrices. So they should be of the same order, right? So if I take a matrix like this, A is equal to A11, A12, A13, A21, A22, A23, which is a 2 cross 3 matrix, and B is B11, B22, B13, sorry, B11, B12, B13, B22, B21, B22, B23 is another 2 cross 3 matrix, and A plus B is going to be like how I told you. A11 will be added to B11, A12 is added to B12, A13 to B13, like this you carry on the operation, right? That is the meaning of this corresponding elements, right? Now, with this example, if you have to generalize and give a mathematical definition in one line, how are we going to do that, right? So in general, if you take a matrix A, which is having the elements Aij, and B is a matrix which has the elements Bij. Ij is not changing, only the way the notation given for element is changing. In set A, the element is Aij. In set B, it is Bij. Right. So these are two matrices of the same order, say M cross N. Right. Then the sum of the two matrices A and B is defined as an output matrix C, which is going to have the element Cij of the same order M cross N, where Cij will be equal to Aij plus Bij. This is going to give you the mathematical representation of elements in C in terms of A and B, right? For all possible values of I and J. Is the point clear? Right? So this is the mathematical definition for addition of two matrices. Just make a note of it. Hello? Chep. Okay. Now, see, there are two matrices which are given as A and B. A has the elements root 3, 1, minus 1, 2, 3, 0, and B has 2, root 5, 1, minus 2, 3, half. So we need to find the value of A plus B. So what is the first check that we need to do even before we go with? First check the order. If the order is not same, there is no answer for it. So here order is, what is it? It is 2 cross 3, right? So what is going to be A plus B? You need to add the corresponding element, root 3 plus 2, 1 plus root 5, minus 1 plus 1, 0. So 2 minus 2, 0. 3 plus 3, 6. 0 plus half, half. That's it. Okay. So from this, the important note that we are supposed to take is, we already know this, but we'll just make a note of it. So we emphasize that if A and B are not of the same order, right? If A and B are not of the same order, then A plus B is not defined at all. It is not possible for you to perform the operation of some of these two matrices. For example, A is equal to, what is the order of this matrix? It is 2 by 2, and here the order of the matrix is 2 by 3. It's not possible for you to add them, right? Second, we observe that addition of matrices is an example of binary operation on the set of matrices of the same order. So here, when I say binary operation, you're taking two elements and just adding them together, right? That's what they're trying to say. And it is like you take a set of that matrices, you add the corresponding elements of that particular set, right? That's what the definition of matrix addition is telling us. You always add the corresponding elements. Am I clear with that? Right. So this point you can actually make a note in your textbook itself. This is from your textbook only. Okay. Clear? Shall I proceed? You don't have textbook, huh? Why? I have it at home. From tomorrow, get it. Both of you. This is Parasa Pusa. Because they have revised so many things. You will know which is there and which is not there. Time is 6 hours. Okay. Shall I proceed? See, you might ask a question, after addition, why am I discussing about multiplication? Okay, from multiplication, here, if you observe, this is actually what we did in the previous case is matrix addition. Here, if you see multiplication, read the heading carefully. It is not multiplication of two matrices. It is multiplication of a matrix by a scalar. When I say a scalar, it's a number. It's a real number, basically. Right? So what is going to happen? From this concept, I will take you to the next step of difference of two matrices. I'll take you to the difference of two matrices, of how difference comes from the concept of addition and multiplication of a matrix by a scalar. I'll relate those two. So understand this. Okay. So Fatima has two factories, A and B. Each factory produces sports shoes for boys and girls in three different price categories labeled 1, 2, and 3. Now suppose that Fatima has doubled the production at factory A in all categories. So what is happening? So we already have the data set. If you remember, this is the previous data set that we have in our hand. So I took it from there. So it is going to be 80, 60, 75, 65, 90, 85. So in factory A, what is happening? The production is getting doubled. So when I say doubled, can I take all these elements and just multiply it with 2? Okay, listen to this very carefully, okay, because we'll be dealing with something like a real number multiplied with determinant in the next chapter also. There and here, there is a small difference I want you to observe. Okay, so when I take a scalar and multiply it with matrix, that scalar will get multiplied with every element in that matrix. Whereas for determinant, it will not happen. Why is it so? We'll see it at that time. But I'm just giving you a hint. Are you able to understand the difference? So you take a scalar, just multiply it with the matrix. Every element in the matrix should get multiplied with that scalar. So what is going to happen here is, how much is the sales increased by? It is doubled. Means each element should be multiplied with 2, obviously. So it is going to be 2 into 180, 2 into 60, 2 into 75, 2 into 65, 2 into 90, 2 into 85. Right? So basically, when you talk about multiplication of matrix by scalar, right? So every element in the matrix should get multiplied with that scalar value. Having said that, see what is going to happen is, based on this, how are we going to define it? See, now from the observation that we saw in the previous example, we'll see multiplication of a matrix by a scalar is as follows. What happens? If I have a matrix A which contains the elements Aij, which is of the order m cross n or m by n. So if this is the base matrix to which I need to multiply with the number k, right? Then k into A is also going to be a matrix. It's not going to be a number, it is going to be a matrix, right? So k into A is another matrix which is obtained by multiplying, this is the most important thing, multiplying each element of A. Don't forget this, multiplying each element of A by the scalar k. Okay, I'm repeatedly stressing this point because I've seen many of them making mistakes in the final exams. Okay, now you will feel like you have understood, but when it comes to the combination of matrices and determinants, right, confusion will start. So please underline these things. Okay. Right. Clear with this? Shall we proceed? Right. So this slide will be the last concept for the day. So from this, if you take an example, let's say there is a matrix A which has the elements 3, 1, 1.5, root 5, 7, minus 3, 205. All that we need to find is 3A. So 3 is a number which is getting multiplied with matrix. So 3 should be multiplied with every element in the matrix. So it is going to be 3 into 3, which is 9. We'll directly write it. 1 into 3, 3, 1 into 4, sorry, 3 into 1.5, 4.5. 3 into root 5, 3 root 5, 3 into 7, 21. 3 into minus 3 is minus 9. Right, 3 into 2, 6, 3 into 0, 0, 3 into 5 is going to be 15. Is that clear? So, since we understood what is the meaning of matrix multiplication with a scalar quantity, that is multiplication of a matrix with a scalar quantity. Don't use the word matrix multiplication, okay? So, there is a difference. Multiplication of a matrix by a scalar is not the same as matrix multiplication by a scalar. Don't use that. Because when you use the word matrix multiplication itself, it means that you're multiplying two matrices. So look at the language I'm using. What did I say? Multiplication of a matrix by scalar is different from matrix multiplication by scalar. So there is a difference in the language. Okay. So here it is, multiplication of a matrix by scalar. Having said that, one last point I would like to stress is the concept of difference comes from the reverse operation of addition. See, for example, if I want to perform the operation of A minus B, can I say it is nothing but A plus of minus B? Can I say? So, if I know the matrix B, right, what should be the scalar value I should multiply to B to get minus 1? Sorry, to get minus B. Minus 1. That is what we call it as negative of a matrix. Negative of a matrix means the negative of a matrix is denoted by minus A, and how is it obtained? By multiplying the matrix with a scalar quantity of minus 1. Is that point clear? So basically from the matrix B, you get minus B by multiplying it with minus 1. Then you will add this matrix to A. This is what is called as difference of two matrices. right? Which is going to be the next topic that we'll discuss. I hope I'm clear, right? So you can make a note of this. So we'll stop with this for today. Okay. So tomorrow, I don't think we'll be able to complete 3.2, but we'll try our best. Next topic என்னன்னு பார்த்தோன்னா difference of matrix and matrix multiplication. So I need to discuss about the properties also. இப்போ இதுக்கு அடுத்தது வந்து properties இருக்கு. Properties of multiplication of matrix by scalar இருக்கு. Matrix multiplication properties இருக்கு. நான் சொல்லி தரேன், don't worry. Simple only. Okay. I hope it is simple. No? Most of you have already learned this already. Hope it is being a good revision for you, right? You're able to remember. Okay. Having said that, we'll wind up. So those are online. Any guys? Sorry, any doubt, guys?
No, sir.
Okay. We'll wind up. Okay. Is there anyone waiting? Ask them to come. Thank you. Fill பண்ணிட்டியா? இல்ல முடிச்சிட்டப்ப போகும்போது பண்ணி. எது என்னென்ன எடுத்தேன்னா சரி பண்ணிட்டு